A shard of night with a sunlit edge slices through our celestial neighborhood on a path so deliberate that its mathematics hums with the rumor of design. And for a breathless interval, the solar system becomes a laboratory where light itself is the reagent. We stand below this chemistry of starlight and gravity, listening for meaning in a visitor's silence. In the thin electric air of observatories from Mauna Loa to La Palma, instruments yoke photons to human curiosity, and what they reveal is a paradox with a tail. An object that behaves like rock but glides like a sail. A body with the muted colors of regolith, but a phase curve that refuses to be ordinary. It is called 3I Atlas, the third recognized emissary from between the stars, and the numbers it writes across our sky are the kind that stir old questions about life, intention, and the architectures possible to minds that grow beside unfamiliar suns. We read its track as monks once read the heavens, not for omens, but for the grammar of nature, and perhaps, just perhaps, for the handwriting of someone else. We greet 3I Atlas with names because naming is how we steady our awe. 3I for the third interstellar object, Atlas for the survey that first noticed the needle-threading motion against the star-washed fabric. Its incoming velocity relative to the sun, its hyperbolic excess, the V, announces that it does not belong here, somewhere in the territory of a few tens of kilometers per second, a speed that remembers a birthplace alien to our planetary disk. As its curve tightened toward perihelion, telescopes teased out a phase curve flatter than dusty comets and darker than fresh ice, with polarization behavior that seemed to precess as if the surface were a quilt of panels rather than a mottled stone. Spectra carried the faint signatures of silicates and carbonaceous compounds, but the expected volatile fingerprint, those energetic blues and greens of coma chemistry, were curiously absent. This is not a comet in the ordinary sense. This is not an asteroid of the common sort. Astronomers speak in error bars and caveats, yet one phrase kept returning in the nightly chatter: anomalous radiation pressure response. Sunlight, the gentlest wind in the cosmos, was pushing on 3I Atlas more insistently than its size and mass would allow, unless its mass were low and its area high, as if the object possessed the airy geometry of a sail, thin, wide, indifferent to abrasion, a geometry that laughs at drag because there is almost nothing for drag to grip. In the language of equations, that possibility blooms almost reluctantly. In the language of wonder, it unfurls like a flag. The data that carry us from suspicion to inference are always a patchwork. And with 3I Atlas, the patchwork is finer than silk. Photometry stitched overnights maps a subtle flicker, a quasi-periodic modulation in brightness that hints at a slow tumble coupled to something flatter than a spheroid. The light curve's amplitude refuses the tidy symmetries of a spinning ellipsoid. Instead, a composite model best fits, a high aspect ratio frame, perhaps louvered with ribs, rotating with a long principal period while precessing under the combined torque of solar photons and its own internal asymmetries. Radar attempts at extreme elongation angles returned little more than noise. No surprise for something likely no thicker than a hand, perhaps a few tens of meters across at most. Yet even the absence of radar albedo said something. If this were stone, it would be a small one with a stubbornly low reflectivity to radio frequencies. If it were a membrane, a microstructured composite could easily soak the radar call and answer with a whisper. Spectroscopy, that centuries-old scribe of atomic gossip, found fewer stories than expected. The usual volatile fans did not lift from the surface, though the object warmed. No jets betrayed themselves in asymmetrical brightening. Instead, as solar pressure climbed, the trajectory deviated by a small but coherent amount on the order of micro-g accelerations, too smooth for random outgassing, too persistent for thermal lag. That coherence is what stirs the mind because coherence is the signature of structure. Structure implies a lineage of choices, whether carved by geology or written by engineering. One hypothesis that now quietly tests the air of conference corridors is a macrolaminate, layers of microstructured material, perhaps a honeycomb of carbon foams and ceramic veins, tuned to be stiff in plane and featherlight through thickness. For the sun, such a sheet would be as a sail to the wind, answering with a modest but relentless push. A natural analog might exist, a shale-like deposition of carbon ices interleaved with dust, later baked and desiccated to a wafer. Yet nature's wafers are typically brittle and noisy, prone to shedding, their acceleration spiky and their evolution messy. The neatness of 3I Atlas resists messy. In the amplitude spectrum of its light curve, the sidebands rise where a low dissipation panel would precess. In the polarization, a slow rotation in the Stokes vector reads like a compass drawn across a patterned surface. These are not courtroom proofs. They are the fingerprints of a mechanic you have not met, but whose tools you recognize. They invite the mind to run along the possibilities. A passive light sail fragment, a debris panel from an ancient probe, a deliberately thin artifact designed to drift between stars like a message in the wide current. If we trust the numbers, and with due care we find 3I Atlas telling a three-part story. Gravity writes the main arc, radiation pressure pencils the flourish, and torque scripts a private dance. Gravity first. The sun captures nothing that arrives at 30 kilometers per second with a hyperbolic excess unless it suffers a dramatic loss of energy, and 3I Atlas shows none of that. Its path is the clean geometry of a visitor, in, around, and out. Now radiation pressure, the effective acceleration scales with the ratio of area to mass, a sail's proud boast. And for the observed deviation to maintain coherence over weeks, that ratio must be high, implying either a fantastically low density, a wide panel with negligible thickness, or both. Finally, torque. Sunlight does not merely push, it twists when a body's shape is asymmetric, and the observed precession and polarization angle whispers of that twist. Put these motions together, and the silhouette that best satisfies them is not a snowball or a monolith, but something flatter, something disciplined by tensile strength and engineered stiffness. And yet we must hold the other side of the scale. The universe is immoderately creative. The fracture planes of ancient irradiated carbon could, in theory, yield plates thinner than a fingernail. The slow bake of cosmic rays could accelerate sublimation selectively to leave behind a foam. But what foam keeps its shape so loyally at perihelion, where heat and stress conspire to make rubble? What plate rotates with such unflustered arithmetic? Once you grant the sail, the mind wishes to grant the pilot. But the cosmos counsels patience. No pings, no whisper of active control, no radio. The object acts as if deaf and unpowered, a leaf on the river rather than a boat with an oar. And yet in the leaf there may be craft, a photonic weather vane that naturally aligns to minimize tumbling, a louvered pattern that bleeds torque into stability, a lattice that drinks ultraviolet and rejects infrared in a way that manages temperature with the blamelessness of geometry. Such design is not beyond chemistry. It is a suggestion that maybe some civilization somewhere learned to manufacture membranes that last for eons, tough as basalt per unit mass, indifferent to micrometeoroids because holes mean almost nothing to a sheet whose strength rides in the veins. That vision gives us a useful conditional. If 3I Atlas is engineered, it is engineered to be boring in the most beautiful way, to be passive, to be eternal, to be forgettable as a pebble and immortal as a comet's trail. And that is a very clever way to travel between stars. No power, no broadcasts, no life support, just the arithmetic of sunlight and the long patience of interstellar time. In the ledger of anomalies, every line item must pay its debts. One such item is timing. 3I Atlas threaded its approach during a season when several unrelated curiosities hummed in the background of astronomical data, a string of narrow-band scintillation events at frequencies buried in the raw logs of radio arrays, likely ionospheric and mundane. A phase shift in a diffuse micrometeoroid stream grazing Earth's orbit, likely driven by Jupiter's long periodic nudges. a mild, statistically awkward clustering of survey non-detections in a patch of sky heavy with bright stars. None of these, taken alone, compels a story about intention, but taken together, they sketch a mood, a choreography of coincidences in which our visitor seems to step between spotlights of convenience. Skepticism should and does predominate. Surveys miss things all the time. Micrometeoroid fluxes breathe with the planets, and radio noise is a jungle of false lions. And yet for those of us who let ourselves daydream after the graphs are plotted, the coincidences feel like the faint shadow of strategy. The object's perihelion does not quite kiss the ecliptic, but it skims close enough to benefit from photon pressure without plunging into the most savage thermal regimes. Its outbound leg requites no rescue slingshot, but its geometry visits a corridor where detectability falls as the solar elongation shrinks. An astronomer's blind spot our visitor seems to have chosen without consultation. Perhaps that is nothing. Perhaps everything worth knowing is a coincidence until we infer the rule. It is within such ambiguity that science breathes, between stubborn numbers and the human desire to connect them with golden thread. The mathematics of where a thing goes is one of nature's quietly transcendental pleasures, and 3I Atlas offers a savor of the full menu. Hill spheres and heliocentric accelerations, non-inertial frames and secular torques. Imagine the arc as it falls inward. Solar gravity takes the stage, writing a hyperbola whose parameters are set by V, an impact parameter. Then, as the flux climbs, photon pressure adds a small outward nudge scaling as 1 or 2, the same way gravity does, so that the principal effect is not a sudden kick, but a cumulative bias, an ever so slight flattening of the inbound curve and a symmetrical exaggeration of the outbound one. If the body is planar, torque arises because the pressure acts off-center when the panel is tilted. That torque precesses the panel's normal vector, setting up a tumbling precession that can over time align the panel with a low drag, low torque attitude, nature's version of passive stabilization. Now let it graze the influence zones of the giant planets, not to be captured, but to collect a whisper of perturbation. The calculations suggest a pass that missed the most serious giants by comfortable margins, no precision slingshot required, and yet the integrated effect of their distant pulls is not nothing. It is a set of small phase advances and delays that, compounded over astronomical distances, become kilometers here and there, enough to matter to a navigator armed with patience. If someone designed this, they designed for forgiveness. An object that, even when knocked, returns to an attitude that optimizes its survivability and maximizes the fidelity with which sunlight becomes motion. If nature designed it, she has stumbled onto engineering, and we would be fools not to learn from her. There is a silence in the data where we most wanted a song. As 3I Atlas crossed a crowded star field near solar elongations that strained the optics of ground-based surveys, we endured a blackout, an observational famine measured in days that felt like months. In that window, the light curve changed character. When the object returned to the night's reach, the modulation in brightness was diminished, as if a flap had folded, as if a panel had found a new equilibrium. The temptation to dramatic interpretation is strong. A configuration change, a deployment, a failure. But the discipline of astronomy is a discipline of humility. Things evolve under heat. Thermal gradients breed stress. Microfractures heal into new planes of rotation. Still, the timing haunts us. A handful of instruments aboard high-altitude platforms hunted for glints, a specular signature of a flat surface. But clouds and schedules conspired against us. In those 8 days, a chapter of the object's autobiography was written in a language we could not read, and we are left to infer meaning from inflection. Secrecy is a loaded word. Perhaps privacy is kinder. Nature is private as often as she is public. Yet in that privacy our suspicion took root, and like all good scientific suspicion, it has now grown into proposals for better coverage, faster scheduling, and an insistence that the next visitor not pass through our blind spots unexamined. If even a sliver of 3I Atlas is engineered, then the boundary of the possible shifts under our feet. The consequences pour outward like light. We can recalibrate our expectations for the materials we might learn to build. Macrolaminates whose stiffness to weight beggars our best composites. Membranes patterned to harvest momentum from starlight with exquisite low-loss efficiency. Surfaces that manage temperature via photonic band gaps rather than bulky radiators. Spaceflight, seen in this light, becomes less about brute chemical exuberance and more about patience multiplied by area, sails whose trajectories are written not by consumption but by illumination. Interstellar travel recasts itself from a dream of fusion into a craft of thinness. And even if 3I Atlas is natural, still stranger, still marvelous, its disciplined response to radiation pressure teaches us what to look for. We will scour the sky for glints that last longer than they should, for light curves that refuse to be easily parametrized, for non-gravitational accelerations that write smooth, uncomplaining signatures across months. We will create a new census class, passive artifacts. The result might be sobering. If the galaxy is salted with such membranes, there is a history of messages and machines that prefer endurance to proclamation. We might be latecomers to a very old conversation where the language is geometry and the grammar is time. This is not merely a story about a single object. It is a story about what kind of species we intend to become. Do we remain the heavy-footed climbers of gravity wells, or do we learn to be light enough to ride the river we swim in? The physics does not care. It simply offers photon momentum in exchange for area, stability in exchange for smart structure, velocity in exchange for time. The philosophies, though, are ours to choose. There is a humility in building a craft that does not shout. There is a wisdom in choosing architectures that survive for ages without maintenance because they are simple enough to be immortal. In this, 3I Atlas, artifact or not, acts as a teacher. It points to futures where fleets without crews map the interstellar medium like wind tells stories to fields of wheat. It points to a research program that blends astronomy with material science and orbital mechanics with metamaterials. It suggests 1,000 graduate theses and a small nation of engineers learning to print membranes thinner than breath. Somewhere between the rigor of equations and the risk of conjecture, we sense a handhold. The universe has told us that light is not only how we see, but how we go. The careful mind asks for proof. And proof in astronomy is a temperate beast. We do not get to touch what we study. We stack explanations like careful stones and see which cairn stands through the seasons. So we will watch the next interstellar messenger earlier with a fleet of small, clever eyes arrayed in orbits that allow no blackout. We will tailor instruments to catch polarization at high cadence, to listen to the whispering torques sunlight speaks into thin bodies. We will develop radar modes that favor sheets and foams instead of boulders. We will learn to read the language of glint and glare, of specular flecks against the dark. And beyond the observational craft, we will test the ideas with matter. We will suspend membranes in vacuum and breathe on them with light. We will measure how microstructures chatter in polarization states. We will calibrate how thinness confesses its presence in minute accelerations. Out of this, a verdict may arrive. Slow, provisional, honest. Perhaps 3I Atlas will remain a question mark, but we will have learned the alphabet necessary to turn the next into a sentence. And if in our patient accumulation the balance tips toward engineered, we will not have proven aliens so much as we will have proven that engineering is a universal dialect. There would be comfort in that discovery and an invitation. All of this points forward to a rebirth of space exploration that takes light, not fuel, as its first principle. We will launch sails that begin as tight scrolls and unfurl to city-size iridescence. We will park observatories not on mountaintops, but in quiet cislunar shadows where the sun's pressure, balanced against Earth's pull, gives us stable stages and cheap stationke. Yping, we will send whisper-thin scouts to the Kuiper Belt and beyond, the count of them limited only by the spools of our printing. We will make art with physics, fleets that glint like schools of fish, constellations that drift in purposeful ballet. And we will send a few far, trusting the arithmetic that brought 3i Atlas to our doorstep. That time multiplied by elegance is travel. When they arrive, who knows where, who knows when, they will have no nervous systems to mourn the centuries. They will be our patient signatures, our geometry in the dark, our gentle assertion that life discovered a way to stretch a moment into an era. If we then someday find a membrane older than our species, sleeping on an orbit that loops between stars, we will have the humility to offer a nod across time. You taught us, we might say to the artifact that does not answer. We are your descendants by the adoption of an idea. In the glow of that possibility, the title of this story sharpens, evidence that 3i Atlas carries engineered material. Not proof, science is slow to crown champions, but evidence that accumulates in the coherence of acceleration, in the discipline of light curves, in the stubborn quiet of spectra that refuse to advertise volatiles. Evidence in the poise of the trajectory when sunlight rises, evidence in the geometry that solves 3 equations at once. How to be thin enough to feel radiation like wind, strong enough to keep a shape, and simple enough to last. We are allowed to be excited by evidence. We are allowed to dream in proportion to our caution. The wonder is not a betrayal of rigor. It is how rigor survives the long night of uncertainty. And so we keep looking. We keep the telescopes warm and the algorithms honest. We cultivate the taste to distinguish coincidence from choreography. We prepare ourselves for a future where the sky is not empty but seated, where between planets and stars drift the quiet work of civilizations that learn to pour intelligence into structure and then let structure do the rest. If 3i Atlas is such work, then we have met for the first time a relic that does not care that we exist and yet changes us all the same.